Good morning, everyone, and thank you for joining us for today's bearing protection best practices training. My name is Sean Clary. I am the e-marketing specialist here at Electrostatic Technology. That's we're the company that manufactures AEGIS Shaft Grounding Rings. Before I hand the mic over, I'm going to go through a few things. First of all, our speaker today is Andy Kressbach, our North American sales manager. Instead of Ken Wagrason, Ken is ill today, so Andy stepped up to the plate for him. Thank you, Andy. For those of you diehard Ken Wagrason fans out there, Ken will return to present a webinar in January. That's on EGIS with electric motors with EGIS Shaft EGIS rings installed at the factory. That will be in late January, I think, about the 20th. All right. You are all muted, so to facilitate a smooth presentation, if you have any questions, we can unmute you from our end at the end of the presentation. You're actually doubly muted, so if you have any questions, then I can unmute you, but you will also need to unmute yourself to be heard. Speaking of questions, the GoToWebinar app has a questions box. If you have any questions, please enter them in there as we go along, and I will read those out and unmute you toward the end. Or if you ask a question that's very topical to what Andy's going over, then I'll try to interject with it. Lastly, we have a handout section where I have uploaded both the presentation that Andy will be using, a copy of our edition 4 handbook, and a technical bulletin on shaft grounding in class 1 Div 2 environment. One last thing before I give Andy the mic, I will put our contact information into the chat box. There's actually wrong contact information in there, so if you go there, ignore the first message. But I will put Andy's and my email addresses in there, and if you want to jot those down, and if any questions come up, you know, if we don't get to your question, or you think of a question later, you can contact us through that. So without further ado on my part, I will turn the microphone over to Andy.
Thank you, Sean. As Sean said, my name is Andy Kressbach. I'm the North American sales manager for industrial for North America. And today's presentation is going to be specifically around AEGIS. Do me a favor, if you have questions, let's get them answered. We're always available to answer questions, whether it's on this webinar or in person, on the phone, over email, whatever the story is. So what we're going to do today is we're going to look at the hang on one second here. So what we're going to do today is we're going to take a look at why bearings fail in motors when they're attached to VFDs, as well as other sources of electrical discharge that will actually happen through bearings. We get to see all kinds of interesting things out there, and we have a pretty good handle on what's what when it comes to shaft grounding. So first of all, we are a division of ITW, Illinois Tool Works. Illinois Tool Works has many different divisions. I think 800 divisions around the world doing all kinds of stuff. The vast majority of them don't say ITW on them, but they're used in other products and all kinds of things. So we are the manufacturer of the AEGIS ring. Electrostatic Technology is the actual company or the division of ITW. So where are AEGIS rings used? And the answer is everywhere. It doesn't matter if it's electric vehicles, whether it's a forklift or a car or a truck or a delivery vehicle. Things very similar to that. The Mars rover, the second edition of the Mars rover now has AEGIS shaft grounding rings in it, whereas the first one didn't, and it's basically tearing up the bearings, and they've got to leave it on Mars. But large AC and DC motors, if you're using a VFD, or if you are operating in an environment where you have products that create static, completely applicable. Industrial, residential, and commercial motors everywhere. HVAC systems, a lot of the HVAC systems that are currently out there use AEGIS, and the reason they do is because VFDs are becoming more common. Generators, this is always one that surprises people. We see generators, standby generators, and they don't fail very often because generators don't run very often. I mean, they have a once a week exercise period, but unless the power goes off, they're not running for extended periods of time. Traction motors, specialty equipment. So the overall fact here is if you have motors and drives, or you're operating in a static inducing environment, you need AEGIS on your motors. That way you get the full lifespan out of your bearings, because we can control the electrical discharge on those. There is a 2-year warranty, and the simplest way to talk about this is that once you put new bearings, or you buy a new motor with AEGIS in it and you register it on our website, we will put an extra 2 years of extended warranty past what the manufacturer has. That simply means that we stand behind our product. So let's jump into what's actually happening out there. So every VFD is what's known as a pulse width modulated, and by the way, inverters, VFDs, freak drives, they're all the same thing, okay? There's just different names for it. So pulse width modulation is the guts of any VFD or variable frequency drive. And it doesn't matter who you purchase, whether it's Yaskawa or ABB or Hammer or GE. It doesn't matter who makes the VFD or who actually, where they're purchased from. Every VFD has PWM, or pulse width modulation, built into it. So what the experts have said, and you can see the dates on here, the first one is 1998, pulse width modulation inverters have recently been found to be a major cause of motor bearing failure in inverter drive systems. That's about the time that ITW started looking at this, and ITW went out and purchased electrostatic technology and said, we have a project for you. They said, we have motors that fail more often on drives than running across the line. So is this a reasonable market? Number two, can you develop a product? Because that's what we do. We work in this static environment. And number three, can you market it and eventually have it go global? That's where we are today. AEGIS is a global product. We have distribution everywhere around the world, and we do a tremendous amount of standard products. Any shaft, it doesn't matter what size it is, can be fit up with AEGIS. And we also make a tremendous amount of custom products. Custom products are very specific, take a little bit longer, but we have a shop that is very useful at actually cranking these things up for us. Why is it important to not have your bearings fail? Well, let's take a look at typical motor failure. Let's go over to the 500 horse column. I deal a lot with big companies and big motors, like in power plants and mining companies and all kinds of stuff. Those large motors, in order to get those things pulled out of there, there's a lot of times where they have to cut a hole in the side of the building because those motors are way too big to actually come out of the building, or you have to have people go in. Production downtime. is the most expensive thing. Because when you take down a big motor, a big motor typically has a spare, or if it doesn't have a spare, now you're really cooked. So whatever time you're down for, that's lost opportunity. Take, for example, in the power generation business. I work a lot in the nuke power generation, and it's $1 million a day to shut down a plant. So a typical shutdown for them is 2 weeks, and they do several different projects in that 2-week period of time, and then they crank it back up again. But it's 2 weeks. That's $1 million a day. That's $14 million that you can never get back in order to move forward with whatever you're doing. Doesn't matter whether it's diapers or dog food or a fiberglass insulation. Doesn't matter what it is. If your plant is down, there will be, it'll create some problems for you. There's 2 sources of bearing currents that we typically see. Capacitive EDM, which is also known as induced shaft voltage. And the reason I use the term induced shaft voltage is because the VFD is inducing a electric charge that is picked up by the motor, and we'll get into this a little bit farther, and is one of the items that's actually going to tear up your bearings or prematurely fail your bearings. The other one is circulating current. Not as common, but it's still out there, and we'll discuss both of these so we have a good understanding of what's going on.
Hey, Andy.
Yes.
We had a topical question. Jim asked, is bearing race frosting also caused by other problems, or is it always and only caused by electric current?
Frosting is, so there's many different things that you can have happen with a bearing. And a lot of times people say, well, there's no electric wires that go to the bearing, so how can it have an electrical charge? The point of this is that when you have damage on the inside of the bearing, whether it's frosting, and if you took a magnifying glass and cleaned up a bearing race where it had frosting on it, and use that magnifying glass and take a look at it, what it is just hundreds of thousands, millions of points of contact where an electrical charge has been driven through the grease, and it goes from the shaft to the inner race to the rolling element to the outer race, and then onto the insulated housing on the motor, or the grounded housing on the motor. That being the case, that electrical charge and what we typically call frosting is one of those things that is going to occur. Not every bearing is going to have fluting in it. I would say probably about 50% of them have frosting in it. But if you have a bearing that has fluting, again, clean it up, take a look at it with a magnifying glass, and you'll find that in each one of those flutes, there is what looks like frosting. And again, it's electrical discharge. And there are many other problems, but spalding, which is created by too much load, or a defective bearing. But there's very, very few defective bearings these days because the production process is very good. So frosting and fluting are exactly the same thing. It's just sometimes it takes a different form, and I see that about 50% of the time.
Do you know offhand, Andy, are there, I'm trying to remember to the different types of bearing damage, are there any that look like frosting?
The only thing that I can think of that may be similar to frosting would be what's called spalding. And spalding is one of those, when the surface of that bearing race starts to come apart, meaning it has the wear surface on the inside of the bearing, when it starts to come apart. But usually that's a bigger type pattern that's on the inside. That's about all I can think of. frosting or fluting is directly related to electrical. Everything else typically is related to mechanical, whether you have an uneven load, so your bearings are riding up on the shoulder, spalding. I mean, there's a lot of different things out there. There's bearing companies have really good picture dictionaries or encyclopedias, if you will, on bearing issues. I would encourage you, if you want to see some of those pictures, go out to the internet and just search around, and you'll find several different examples there. Sean?
Okay, thanks, Andy.
You bet. So let's jump into this here. Electric motors, it doesn't matter what size your electric motor is. It could be a 2-horse, it could be a fractional size, could be 20, 200, 2,000 horsepower, it doesn't matter. Those motors, any electric motor, AC or DC, loves to run across the line. But if you don't need all that horsepower, say you have a motor, say you have a 500 horse motor and it's attached to a pump, the result here is that you're going to run that motor at 1,800 RPM or 3,600 RPM. You really don't have a choice unless you want to start doing stuff like using mechanical speed controls or that kind of stuff, or you're going to use something like a VFD. So motors typically do very well running across the line, meaning no VFD in it. And what's happened here is in the last 25, 30 years, VFDs have become very popular because they save a tremendous amount of energy. Say you have a pump motor and you don't need to pump, 5,000 gallons a minute with it. Okay, well, what happens when you want to slow down your production line? You can actually slow down your motor. And think of wastewater treatment. You have different times of demand. So in the morning, you have a big demand, and in the dinner time and evening, you have a big demand. So you use VFDs in order to make sure that you are taking care of business, essentially. So now what happens here is if we take a motor and we put a VFD on it, that little diagram above the motor on the page that's up there right now, what a VFD does is it matches the sine wave, and this only has one sine wave on it, and I know the previous example had 3 sine waves on it. This, just for clarity, what's happening here is that a drive fires and it matches the sine wave. When it doesn't match the sine wave perfectly, that's when you start getting an electrical charge that doesn't have a purpose out there, and it's going to be attracted to the motor from the VFD. It's going to be on the stator, and then it is going to transfer, called coupling, over to the rotor, because the rotor is acting as a capacitor. Here's a good example of it here. You can see where your rotor is mounted on non-drive end bearing, drive end bearing, and in this case, say this is a pump motor, down the shaft if you have a conductive coupling and into your driven equipment. Well, the problem here is that if we allow that electrical charge to continue, it ends up prematurely failing the bearings. It is important to understand that once you start this process, once you rough up the inside of the bearing, and then say you were like, oh, we got to put on some sort of actual shaft grounding device. Well, the problem that you run into is you've already roughed up the inside of the bearing. So if you go and are going to use shaft grounding, make sure, number one, you're using the one that's going to give you the best performance over a long period of time. AEGIS publishes 200,000 hours of runtime specific to the AEGIS ring, which is double the lifespan of the bearings, because the bearings are typically L10 or 100,000 hour bearings. This is their mechanical lifespan. So if you get 100,000 hours or 10 to 12 years out of a motor that's running continuously, great. And a lot of times people look at this and say, well, not every VFD does this. My motors don't do this. About 50% of motors running on VFDs have an issue. We've actually done some testing with lots of different places that have a tremendous amount of motors in them. I did a data center a few years ago, and we tested, I think, just about 100 motors. That's a pretty good sample, and we've done it in other places. And what we found is that about 50% of them, and we tested with an oscilloscope, and that's the gold standard for knowing what's actually going on there. But we tested just about 100 motors, and about 50% of them showed that specific sine wave or that specific trace on an oscilloscope. That means that you have premature wear in your bearings because they could pick up electrical charges there. So the rotor of the motor picks up that, it ends up acting as a capacitor. Anything that's rotating, it doesn't matter if it's a hydroelectric electrical generation, or whether it's a pump motor, or whether it's on a conveyor or whatever, the process is still the same here. Here's another interesting fact. In order to make motors premium energy efficient motors, the US government mandated that you had to have a certain amount of these, and you had to have a certain efficiency out there for motors. That being the case, motor manufacturers said, okay, we will go through and we will make our motors premium efficient. One of the ways they did that is they brought the rotor and stator closer together. 25 years ago, you could stick your hand in between a rotor and stator on a large motor. And not running, of course, but there was plenty of room in there. What they did is they took and they reduced the amount of room in between the stator and rotor. By doing that, it's easier to conduct an electrical charge between the stator and rotor. Okay, well, if you have stray current from a VFD, that stray current is going to be more easily connected to that rotor, acting as a capacitor. And the result is that every time it discharges, you're going to see this. And there's oftentimes that we are at industry and people will say, hey, I never had this problem 25, 30 years ago, but now I've got it all over the place. That's one of the reasons for that, is that by bringing the stator and rotor closer together through with electric motors, that will allow more energy or stray energy to connect to that rotor, acting as a capacitor, and eventually create bearing failure. So what we do know is that when the electrical charge builds up on the rotor, that electrical charge it wants to go someplace. It's just not going to sit on the rotor. It's going to take the path of least resistance and a path to ground, or paths to ground. In this example, we have a motor and a load, or a driven load, and that rotor doesn't touch anywhere else except non-drive, drive end, and down the shaft into your driven load. So the result of that is that when you send an electrical charge through a bearing, really doesn't want to go through there, but it doesn't have much of a choice. So it ends up burning the grease. So say you use Polyrex EM. Polyrex is kind of Caribbean blue or green, and it turns jet black. Once it turns jet black, then what happens is, by you keep on sending an electrical, you actually have to burn a hole through the grease, because the grease is dielectric. It does not support an electrical charge or transmit an electrical charge. So it actually burns a hole through the grease. And this happens anywhere between 0 and about 100,000 times a minute. Sounds extreme. Pretty average, 15 to 20,000 times a minute discharge. and you can actually see that on an oscilloscope. So the result here is that when you have a buildup on your rotor, it's going to go from your shaft to the inner race, to your rolling element, to your outer race, to the house of your motor, which is grounded, and you don't want it to go through your bearings. An interesting thing about grease also is that when you have grease that is being tortured inside of a motor, it will eventually separate the lubrication from the emulsifier. The emulsifier being soap or wax, that's what makes it sticky, and then the lubricant is what makes things glide easily. Well, when you take the lubricant out, because the lubricant is, you're separating it, and it's going to end up on the bottom of the end bell on the inside on a horizontal motor. The result here is that you have just the emulsifier left inside the bearings, and it kind of looks like black candle wax, and it's nice and stiff. So that isn't doing anything for your rolling resistance. In fact, it's raising it, not lowering it. And when you actually create the situation where you rough up the inside of the bearing with fluting or frosting, that creates more problems on the inside of the bearing, and it's very quickly wears out that bearing. So you can hear some noise, but it doesn't take too long if you run that motor to actually tear up the bearings pretty quickly in there. The gold standard for testing motors is an oscilloscope. This is a standard oscilloscope. It's a 200 megahertz, I'm sorry, 100 megahertz oscilloscope. And the 100 megahertz oscilloscope, you have to have a fairly fast scope in order to pick up these discharges. The discharges will, and let me zip ahead here for a second. This is what a trace looks like on an oscilloscope. And right in the middle of the screen, you can see where it goes, starting from the left-hand side, going to the right. It takes a large swing up and then a straight line coming down. The line that is on an angle is actually the buildup of voltage on the rotor, and the discharge is shown as a straight line because when electricity moves, it moves fast. So you can actually see the difference here. But if you look at the base of that actual discharge in the middle of the screen, you're going to see that it's about 10 to 12 microseconds from the time it builds up to the time it discharges. There's a million microseconds in 1 second. So this is happening really fast. That's why you need a fairly fast scope. These scopes that we have are already set up for doing motor testing. They come as a complete package, and we have training on this kind of stuff so that anybody can actually use this and test motors. It only takes a couple of seconds to do that. One of the things that, or one of the small details here, you can see in the picture in the lower left-hand side where it says EDM pit. That's a fancy word. Electric discharge machining is a fancy word for a spark hitting a metal surface and creating a defect. These are highly magnified pictures, but the point of this is every time you have an electrical charge that passes through the grease and hits the next surface, it actually damages that surface. And we talked about it earlier, there's frosting or fluting that can actually occur in there. EDM pitting is just, it's what happens when an electrical charge hits that surface. So the result here is frosting or fluting. Frosting is just millions of points of electrical contact where that electrical charge has gone through. And if you have a horizontal motor, typically the rotor is going to have a thinner grease film inside of the bearing on the from 3 o'clock to the 9 o'clock position, meaning the lower portion of the bearing. So that's typically where you'll find frosting or fluting. But on a vertical motor, you'll find it actually all the way around because your pressure is even all the way around on bearings, say your thrust bearings or your guide bearings on your vertical motors. So these are the two conditions. A while ago, I was in a motor shop and asked him, I said, what is the most common thing you see when it comes to damage in motors? Doesn't matter what it was. And right off the top of their head, they said, it's electrical discharge. We see frosting and fluting more than anything else out there. So there you go, right from the horse's mouth. So in order to actually take a look at this, here's a fairly large inner bearing race, and you can see where not everything is perfect like you would see it in one of our other pictures. What's happened here is that you have frosting, and then you're having these lines that start building up that go across the bearing in the detail circle there. Here's another one where this is just the beginning of fluting. And what's going to happen is when you run it, the fluting actually takes place because the PWM drive is going to fire and eventually creates this kind of situation. So this is the beginning stages. You can start to hear this, but it only gets worse because mechanical wear, once you rough up the inside of that bearing, it will continue to get worse. And then if you don't do something about the electrical charge, it gets worse even faster. I was talking about grease before, and this is a pretty good example. You have a bearing race and a cage for your balls here, and they're using a food grade grease, which is cream colored or very nearly white. And then you take a look at the bottom and you can see where it looks like somebody smeared some mud around on the rolling elements there. This is just burn grease, and burn grease does not have the lubrication because it drains off, and then you're left with the emulsifier. So if you take apart bearings and take a look at it and say you're using a blue or a green grease and it's jet black, or say you're using a cream colored grease and it's the color of mud, that is not wear inside the bearing. That is actual electrical discharge creating that problem for the grease in there. So there's a couple of different ways you can tell what's going on. You can cut and inspect, pulling bearings out, cutting them open. If you are a consumer of bearings, meaning with your electric motors, and you send something to a motor shop, make sure you ask them for pictures of the inside of the bearing, because it will tell you exactly what's going on. You can ask them for a report. Reports are very common because the tech actually details this as he's taking this stuff apart. So if you find either frosting or fluting on the inside of a bearing after cutting the bearings open, that's a guarantee that you have an electrical problem. Or you can use an oscilloscope. Oscilloscopes are not expensive, and you can very accurately tell whether you have electrical discharge or not. And this is not something that's going to come and go depending upon usage. This is once you start a motor up, if the drive and the motor, that 50% of those motors that have that issue, it will tell you that very quickly there. Once you solve the problem, and you can see on the right-hand side, there's Polyrex, which is blue, and then the bearing behind it is Polyrex also, but it's been run. And a lot of times people think that that's just typically what you have in a bearing. No, I've seen motors that are 4 or 5 years old that the grease is still blue in them. But if you have partial black grease, or you have almost all black grease in there, it is going to create a problem, meaning that you're not going to have that motor operating very long because of premature failure. So that's the basis of what happens with electrical discharge because of VFDs. The second thing that I mentioned here is circulating current. And circulating current is kind of interesting because circulating current is caused by in a differential field in the motor from one end of the motor to the other. It can also be, it can be caused by more windings on one end of the motor than the other, air gap difference, even slight differences. You'll find this. But what you're going to also find is that it's typical on 100-horse motors and above. In the 14 or 15 years that I've been doing this, working with shaft grounding, what we found is that very, very few motors under 100 horse have circulating current. These voltages build up, they pass around in the motor itself, and when it builds up far enough, it's going to discharge through the bearings, and it will mimic electrical discharge because it is, but maybe you don't have a VFD. So this is something that can happen out of it. The fix for this is to simply use an insulated bearing or an insulated sleeve on the non-drive end and use AEGIS on the other. This is a good example where you have an AEGIS ring, you have colloidal silver shaft coating, which is part of our install procedure. You always want to use the colloidal silver. It only costs a couple of dollars per application for the silver. And there's enough silver, say you were going to do 20-horse motors, you can probably do 30 or 40 of them with what's in that bottle. So not a problem. Silver is 10 times more conductive than regular shaft steel. So that's why we use it in the interface between the conductive microfiber and the shaft. We want to give that shaft grounding ring, and we want to be able to pull off as much electrical charge as possible before it goes through the bearings. Protecting your motor from both induced shaft voltage and high frequency circulating current is as simple as installing AEGIS with colloidal silver and use a high frequency ground strap. Ground straps alone will not do it because you have to be able to take that current off the shaft effectively and over a long period of time. And then once you do take it off, you want to give that high frequency discharge, which is very fragile, a good path. And that's why we use a high frequency ground strap on that. The high frequency ground strap, when we first invented the AEGIS ring, we really hadn't thought about that much, but through extensive testing, it does a better job than just a standard ground. You want to have as little resistance on that ground wire as possible. And a braided ground strap has many, many wires that is set up in a ribbon type pattern. The other reason why you want to use ground straps or the high frequency ground strap is that AC current travels on the surface of a wire as opposed to DC, which travels all the way through the wire. So the greater the surface area on the wire for an AC motor, the better off you're going to be, the more effective that's going to be. So that's probably the least expensive portion of doing any of these fixes for shaft grounding. So we've covered two things. One, induced shaft voltage, and we also covered circulating currents. There's other areas. Say you have a motor and it is running a production line and you're making non-woven fabric, like what you would find in baby diapers or, that kind of fabric. Or say you're manufacturing carpeting or maybe mylar sheeting or any one of the products that can create a static charge. And it doesn't take much of a static charge. Even if you don't have a VFD, a static charge will find the path of least resistance to earth ground. So say you have a conveyor with rollers that are non-powered, but they're pillow block bearings on either end of that roller. One of the things that's going to happen is you're going to have a pillow block bearings that are going out on a regular basis. And I've had people say, gosh, there's no wires. These are not powered rollers. Doesn't matter. The static charge is on the products that you're producing, whether it's paper or whether it's non-woven fabric or polyester or nylon or anything like that. So what AEGIS has done is we have a full suite of different products. Starting on the left-hand side, we have a split U-kit. A split U-kit allows you to put a AEGIS shaft grounding on a motor without uncoupling it from its other equipment. Because anytime you do that, now you need relays or aligning, that kind of stuff. So we manufacture the vast majority of our products in split. We make large rings, small rings, and everything in between. Standard SGRs or shaft grounding rings start at about 1/3 of an inch and then go all the way up to 6 inches or 6 1/3, something like that. And then we transfer over into a larger ring, which has, instead of 2 rows of fiber, has 6 rows of fiber in it. And these go on the larger machines, and it works really well because as you go up in shaft size, you're also scaling up the size of the ring, so you're actually putting more fiber on that shaft to take off any type of electrical energy that's on there. We do all kinds of rings for many different kinds of uses, and those products are the AEGIS shaft grounding rings. We have on submarines in the ocean, in outer space, like on Mars, the space station, all the cellular phone satellites that circle the Earth. These things all have solar panels. They need to keep them pointed toward the sun, and the motors are VFD controlled. So you actually need some sort of shaft grounding device in them because you can't go up in space and fix those things very easily. There's lots of different types of competitive products out there. Give you an example, single point, which we have up right now on the left-hand side, is a typically, a carbon block type thing. So it's gonna touch a very small amount, even on the shaft, whereas the AEGIS product has 100% coverage, all 360 degrees of that shaft, and that's and the conductive microfiber does not actually need to touch, but it will ride right at the surface, and it will pull off that energy very easily. Here's a good example of a carbon block. They get gummed up, they're spring loaded, stop working, they have glazing on the shaft. Any of those things will create a situation where it looks like you have shaft grounding, but you really don't. On the other hand, take a look at the AEGIS, maintenance free. It does not pollute the environment with all kinds of carbon. Zero friction, or virtually zero friction on there, because the fiber after the wear-in period will actually ride right at the surface. So this was designed to work better than any other shaft grounding device right around 2000 or 2002. And then when we introduced it to the market, it went global. This is how it works. Tunneling of electrons, field emission of electrons, and Townsend avalanche of gaseous ions. And it's known as nanogap electron transfer because the fiber doesn't have to actually touch, but it will ride right at the surface. That's how we get 200,000 hours of runtime out of these things. And you don't have any type of, you don't have to do anything to it. It's virtually a maintenance-free product. Left-hand side, this is a little bit of an exaggeration, where the fiber is actually lays on the shaft by a small amount, about 10/1000ths of an inch. And then the right-hand diagram shows you that fiber riding right at the shaft, but not laying on the shaft. So that's how the actual ring is going to work. If we take a motor that has an issue, left-hand screen, which is from the oscilloscope, you can see it has 20.2 volts on the shaft. You want to get everything under 1 volt as often as you can. Once it's under 1 volt, you really don't have that issue. But the left-hand picture is the one that has not been treated with shaft grounding, AEGIS shaft grounding. And the right-hand picture is after you have put that on, now you have a proper screen which will say you don't have an electrical discharge that's rolling through your bearings. We have the bearing protection handbook, and this is actually edition 3 that's in this, but we have a new one which is called edition 4. I believe Sean has attached that so that everybody can download that and take a look at it.
That's right.
Go ahead, Sean.
I just said that's right. The handbook and some other resources are in the download set, in the handout section.
Super. That bearing protection handbook, if you want a hard copy, we'll send you a hard copy, or you can be sent to you as a PDF. It is really beneficial. We've taken a lot of time and a lot of energy over the years to make that book about as complete as possible. But if you have questions, please call us. That's not an issue. So let's take a look at some individual motors. Say you have 2 insulated bearings. You absolutely want to use a shaft grounding ring on that. We had a case a little while ago in a manufacturer of paper mill, and the paper mill was having problems with a 600 horse roller motor. And they said, they called a bearing manufacturer, or actually a distributor, and said, what's the best solution for this? And the distributor said, well, you put in insulated bearings and you will not trash your bearings anymore. Well, the fact here is that is the case, but that 600 horse motor is connected to a gearbox, and that gearbox is problematic because a 600 horse roller motor is about $50,000. The gearbox that it's attached to is about $250,000. So there is a high cost to pay for putting in insulated bearings and then not using shaft grounding, because that electrical energy will travel to many other places. That specific example that I'm talking about, they actually have a 8-foot jack shaft between the motor and the gearbox, and that electrical energy that was taking out the bearings previously, before they put in the insulated ones, had no problem traveling the 8 feet on that jack shaft and into the gearbox. So the point here is that these electrical charges will travel fairly long distances, and you have to make sure that you treat those by pulling them off and putting it to earth ground.
Hey, Andy, we have a question related to that slide. Larry wanted to know, and Larry, I've unmuted you. Wanted to know, is there any benefit to having insulated bearings on both ends?
Well, I will give you probably the best example I can think of here. Anytime that we work with manufacturers and they have what is known as production motors. A production motor is simply a motor that runs 24/7. You're running it for 3 shifts. An example is paper or steel. Once you crank those mills up, you want to keep them running because that's the most efficient way to run them. You can't take them down, start them up, take them down. It takes a while to get it right. There's almost an art to steel or paper making. So anytime there's a production motor, what we do is we say, do yourself a favor, put in 2 insulated bearings, and then use AEGIS with the colloidal silver, CS015, and use a braided ground strap. that has been a real good fix for a lot of motors. So yeah, taking what we normally suggest is one insulated bearing on the non-drive end and then an AEGIS on the other. But for production motors that run 24/7, I simply make the recommendation of putting in 2 insulated bearings, one on either end, and then using shaft grounding. Sean?
Awesome. Thank you.
All right, thanks, Larry. Andy, I've actually got a follow-up from Paul, if I can find him here to unmute him. Paul asked, when you say insulated bearings, are you referring to ceramic bearings? And Paul, I'll unmute you from our end. You can unmute yourself if you want.
Let me explain the differences in bearings here, and this is just very basic. First of all, you have a standard bearing where you have roller, ball, or angular contact, and everything's, inner race, outer race, and the rolling element is steel. When you have an insulated bearing typically is referred to that it has a non-conductive coating like aluminum oxide on the outside of the outer bearing race, so that when you have put this into the bore, that the bearing itself is insulated from the rest of the motor. And then the third type is what's called a hybrid bearing. And a hybrid bearing typically has a rolling element that is a ceramic ball or a ceramic coated ball. The best performance when you have electrical discharge really depends upon what's going on. But if we have a problem that we just keeps on occurring again and again, we default to hybrid bearings, but they're not, you can't get all sizes in it. So it really depends upon what you need there. So those are the 3 different broad categories of bearings. And then there's everything else in size and, shape and function, all that kind of stuff on bearings. Sean?
All right, no word from Paul, so it looks like it's good enough. Okay, thank you, Andy. You can carry on.
So it doesn't matter whether you have cylindrical, roller, Babbitt, sleeve, really doesn't matter. I will tell you that if you have a Babbitt bearing, and this is typically on larger motors and also DC type motors, what's going to happen here is that you the pattern will look different inside of a Babbitt bearing, but it's electrical discharge all the same. It kind of looks like if you have ever had moles in your front lawn, that's what it looks like inside of a Babbitt bearing. A little bit different than the fluting or frosting. But we don't see anywhere near as many Babbitt bearings as we do the roller or ball. Vertical motors typically have a thrust bearing at the top and a guide bearing at the bottom. One of the things that we found on vertical motors is that there is a bearing carrier, and you can see that bearing carrier in the upper left-hand corner has that white stripe on it. What that does is that takes your thrust bearing, and because there's a lot of weight hanging on that bearing, the whole weight of the rotor and the shaft and everything else is hanging on that thrust bearing. The thinner the grease film that you have inside of the bearing, the easier it is for an electrical charge to travel through and cause damage. So this is a method with vertical motors that works exceedingly well and was developed probably about 12 years ago. And there's a lot of motors out there now that have insulated bearing carriers. So it's a product and any motor shop typically can do it for you. So Pro Series, the Pro Series is just a bigger ring, 6 rows, typically used on bigger equipment. We have all the suspension systems specifically for it. You can see this one has spacers and mounting mounting bars on it. But we make all this specifically so that your individual situation, that we can actually make that happen for you. Pro Series starts at about 2.5 inches, I believe. Yeah, 2.5 inches is about as small as we can go with it. But there's not very many big motors that have 2.5-inch shafts on them. And we produce this, it doesn't matter whether it's metric or standard, or whether you want metric or standard screws or bolts or that kind of thing. Internal installation as opposed to external, you can take shaft grounding rings, whether it's small ones or large ones. They can go inside or outside. Really, the determining factor here is what type of environment are you in. Typically in a paper mill, there's a lot of paper fiber flying around in there. So we like to get those on the inside of the motor as opposed to mounting them on the outside, because they end up being a dust collector is what it comes down to. But I've seen some motors where I can't even find the ring and it's working just fine. So the less particulate matter you have, or the less grease on them, the better off you are. This is just a breakdown of a typical hardware package for a shaft grounding Pro Series ring. We come up with all kinds of solutions. Really doesn't matter what it is. If we have a picture of your motor boss and we know what the shaft is and the shoulder is, those kinds of things, if you need it, we can come up with a custom solution on it. Some of them are rather elaborate. These go into power plants. It just depends upon what actually needs to happen there. So when we produce this kind of thing, we provide 3D drawings, and this is typically for the custom work, color coded, so it will list out what each item is, and they're plug and play. We want them to work without having to do anything to them. You can see there's other types of rings out there too. This is a Pro Series ring, and it actually has an O-ring, a rubber O-ring mounted on either side of that. So say you're in a dirty environment, but you can't fit it on the inside of the motor, or you don't have the time to do it or whatever, you can actually order something with O-rings, which is a Pro SLR. SL stands for slimline, R stands for ring. So we do produce all different kinds of those things. Promax is those are fairly large rings, and they have to have a heavier body on them, because that heavier body is will become unstable if it's not machined out to a thicker standard. So Promax starts at 15 3/4 inches and goes up as high as you want. We also have things called monitoring rings. There's a monitoring ring that is isolated from the standard ring that you can take back. You can take the wire back to central station and actually check it without having to go up to the motor. These are used a fair amount in power plants. So Sean, any other questions? Because we're getting down to the end of this.
Yeah, we have about 5 questions left in the queue. For all of you who are still with us, we have more questions. We are at the end of the hour, as Andy said. If you're not able to stay around, we will be sending a link. This webinar is being recorded, and we will be sending you a link to that recording within the next couple of days. So if you need to drop off, don't feel too bad. But if you don't have to, then stick around and we'll have some more questions. The first or next question is from Greg. He asks about the braided grounding strap. Should this strap be used from the motor base back to the VFD? And Greg, I'll unmute you from our end. Yep, you're on top of it.
Yeah, that's one way of doing it. You can take a wire and go back to the VFD, or you can actually go directly to earth ground from the foot of the motor. If you have to grind off the paint though, because paint is non-conductive. So anytime you're installing AEGIS as well as grounding straps, that kind of thing, make sure you think path of conductivity. If there's any question on it, grind off the paint, put some colloidal silver on it. Silver is 10 times more conductive than regular paint. So it will actually, you can use it on screw threads, you can use it on, attached a ground strap. It is important to make sure though that you have that path of conductivity. Okay, Sean?
Right. Did that clear everything up, Greg?
Yeah, the concern was that the discussion of a high frequency type discharge, and that's the benefit of your braided cable. But then you take it to earth ground and you're really trying to bond it back to the VFD to complete that loop. And so how is the earth ground sufficient to dissipate that stuff and the timeliness that the bonded cable or your special cable gives?
I see it done both ways. I can't tell you the percentages, but it's about equal, going to earth ground. And there's never a problem with going from the outside housing of the motor to directly to earth ground, or going back to your drive. I don't see any difference in that.
Yeah, and then the second aspect of that, of course, would be that you would have to make sure that you've got a definite ground path between the two devices, right? The VFD and the motor. Yeah,
you definitely want to test for a ground. Let me just give you a quick primer on grounds. Grounds are based upon ohms of resistance. If you have 5 ohms of resistance or less on a ground, that's a very good ground. But say you have 50 ohms of resistance on the same ground, it looks good, but it's not working because that high frequency discharge is not going to put up with a whole lot of resistance on that line. So I see it both ways, and I haven't heard anybody say that one way is better than the other.
Okay, thank you for that.
Mm-hmm. Sean?
Right, thanks, Greg and Andy. All right, our next question is from Larry, and Larry asks, can these rings be used in Class 1 hazardous areas?
They can, but first of all, you can never mount this on the outside of a motor. AEGIS rings are classified as a sparking device by UL. I've never seen any sparks come off of them, and that's the terminology that UL used. So anytime you have a Class 1 Div 2 situation, you want to make sure it goes on the inside of the motor, and the motor has to be specifically set up to work in a Class 1 Div 2 situation. If you go to our website, go across the top of the page, go to resources, and then it'll bring up a menu, and the second item down is IEEE. If you click on that, it will give you a very good description of what you need to do in order to make something work in a Class 1 Div 2 situation. John?
Yep,
Perfect.
Larry and everyone else. I'll also point out that one of the handouts is a technical bulletin on recent changes in electrical codes and IEEE standards. Which is what Andy was referring to. The other thing is that basically what it comes down to is you need to do a series of calculations which are difficult for you as a user to do. However, WEG Electric has done all of those calculations for a few line of its motors. It's the W22 line. I believe that they're cast iron frame. It's either cast iron or rolled steel, and they are now they're available, certified for use with shaft grounding in Class 1 Div 2 environments.
Great, thank you.
All right, you're welcome. All right, next question comes from Pedro, and Pedro asks, how long is its useful life and how does it behave in coastal environments? I'm thinking of using it in an oil refinery. And Pedro, as soon as I find you, I will unmute you from our end. There we go.
So as far as using shaft grounding, we manufacture the base of the product typically in aluminum, which will not rust, or you can get it in stainless steel. We produce a lot in stainless steel for chemical plants and refineries and all kinds of situations. The conductive microfiber is not bothered by a salt environment or a moisture environment. It's not a problem. The only thing that I see is that when you have a shaft that is exposed to salt or moisture, if you don't have a stainless shaft, you're going to have corrosion on that shaft. Typically, in that case, it's best to put it on the inside of the motor and use colloidal silver on it. The colloidal silver coating will retard any type of rust corrosion, and the inside of a motor is typically better protected than the outside of the motor. But if you need to run them on the outside of a motor, I don't see where there's a problem with that. Sean?
Okay, thanks, Andy. Let's see, that was Pedro. The next question comes from Democritus, who has actually left, but he asked, is dust or dirt in general a degrading factor considering the nanometer-sized gap between the fibers and shaft?
If you have a shaft that is rusting, and if you take a piece of metal and just put it out in the rain or expose it to the elements on the outside, what you're going to find is that the corrosion or rust actually has a tendency to bubble up. And then when you have that rust that's on the shaft and you start your motor up, what it's going to do is it's going to wear that back. So it is important that for the top performance in a shaft grounding ring to protect that. If you have to run it on the outside, make sure you're putting colloidal silver on there. That will do a really good job of retarding corrosion, and it will eventually wear off. But if you have motors that are run intermittently and they start developing rust on them, I would put them on the inside of that motor. Or purchase them with it on the inside of the motor. Many, or just about all motor manufacturers will put them on the inside of the motor, not only as stock items, but also as a mod. But if you have to mount it on the outside, use colloidal silver, and I'd say go in there and coat it once a year just by backing that ring off, putting a coat of colloidal silver on there. There's an applicator on the cover on the inside. So just by shaking it up, putting a coat on there, letting it dry for 60 seconds, and then putting the ring back on will give you pretty decent protection. Sean?
Thank you, Andy. It looks like that is everything. We do have I was just replying to Pedro in the questions box. He's looking for case studies in mining and oil refineries. And we do have a number of case studies and application sheets, but we don't have any in those particular sectors, unfortunately, very unfortunately, because those are, they use a lot of motors. So yeah, Pedro, unfortunately, we do not have case studies for mining or oil refineries. We do have an application sheet on petroleum processing, but it doesn't have any any particular details. It's just about ways that you could use shaft grounding in a plant. And That looks like all of the questions. If anyone is interested, those the case studies I alluded to are on our website, EST-AEGIS.com, and in the menu bar at the top, you can choose applications, I believe it is, and that's where you can find those case studies. But it looks like those are all of the questions. So thank you, all of you, for coming and for your attention. And as I said, we will be sending out a link to the recording within the next couple of days. Because this was a 4-credit training, I'll also be sending you a certificate for professional development hour if that interests you. So keep your eye on your inbox. And have a good day, everyone.
Sean, thank you. I appreciate it. Take care.
Thank you, Andy. Bye now.